For over a century, the functional hierarchy, a rigid, pyramid-like structure, was the undisputed engine of corporate productivity, designed specifically to prioritize top-down control. But that model relies on a static environment. Today's market is defined by VUCA. VUCA is an acronym standing for volatility, uncertainty, complexity, and ambiguity. In this volatile landscape, market conditions shift faster than traditional communication channels can process the data. The primary liability of the hierarchy is vertical latency. This is the delay when information must travel up a chain of command to a decision maker and then travel back down to be executed. This diagram shows how vertical latency creates fatal bottlenecks. Data from the ground floor gets trapped waiting for executive processing, turning a former organizational strength into a severe competitive disadvantage. Fixing this delay requires dissolving the fixed, position-based pyramid into a fluid, decentralized node map. High-performance organizations are replacing vertical command and control with decentralized networks to keep pace with modern information flows. The fundamental unit of this new architecture is the node. A node is an individual or a cohesive pod that possesses high autonomy and specific accountabilities, rather than a fixed job title. These autonomous units coordinate using a blueprint from telecommunications, self-organizing networks, or SON. SON technology allows mobile radio access networks to maintain equilibrium and performance without a central controller. This network diagram shows the first capability of the SON triad, self-configuration. A new node can automatically sense local parameters and plug into the ecosystem to establish working relationships, which eliminates the need for manual onboarding. The second capability is self-optimization. Nodes continuously analyze their performance relative to the network's goal. They dynamically reallocate resources to balance traffic loads, which research suggests can reduce operational expenses by 15%. The third capability is self-healing. This is an anti-fragile mechanism, where if a node fails or a project stalls, the surrounding network instantly senses the gap and reroutes responsibilities to ensure service remains uninterrupted. Embedding these capabilities at the fundamental unit level eliminates single points of failure. The organization gains the ability to maintain a stable service level even under extreme internal stress. Without a top-down command, decentralized nodes must find a way to coordinate complex tasks without descending into chaos. They use a mechanism called stigmergy. Stigmergy is a biological method of indirect coordination, where actors interact solely through changes made to their shared environment, as seen in the architectural feats of social insects. In human digital work, stigmergy operates through shared artifacts. One node leaves a trace, like an initial idea or piece of code, in a shared medium. That alteration stimulates the next logical action by a completely different node. The shared artifact functions as the manager. It offloads the coordination burden from individual human communication directly into the digital environment itself. Stigmergic coordination allows a network to scale exponentially. It processes highly complex distributed tasks without the linear increase in bureaucratic friction that paralyzes traditional hierarchies. In a decentralized system, formal titles vanish, leaving a node's topological position to dictate its actual influence. This visual represents an organizational network analysis, or ONA. ONA is a diagnostic tool that maps the true, informal flow of trust, advice, and information across an enterprise. Within this map, degree centrality measures a node's direct connections. High degree centrality indicates popularity, but it also identifies a severe overload risk where an individual becomes an information bottleneck. Betweenness centrality measures nodes acting as brokers across structural holes. A structural hole is a gap between two unconnected groups in a network. Brokers bridge these gaps, facilitating cross-functional coordination. If this single broker node is removed, the organization immediately fractures into isolated silos, losing its ability to synthesize ideas from disparate sources. Eikenvector centrality reveals the hidden influencers. These nodes may lack formal titles, but they hold immense weight because their connections tie them directly to the most critical hubs in the network. This topology optimizes for the strength of weak ties. Sociologist Mark Granovetter established that innovation relies on these distant, bridging connections rather than the echo chambers created by close colleagues. leaders who understand ONA metrics can proactively design networks. By mapping the actual social architecture of the firm, they can optimize for cross-pollination and mitigate silent points of failure. The real-world performance of these networks is determined by agency costs, the costs associated with conflicts of interest and information asymmetry. Hierarchies excel at processing hard information, which consists of costless, verifiable facts like sensor data. However, they heavily distort soft information, context-dependent insights like a manager's assessment of a worker's character as it moves up the chain. Pushing decision rights down to the localized node eliminates this distortion. The node closest to the context acts on it immediately, which resolves the friction caused by information asymmetry. Hire's Rendon-Haye model demonstrates this success. Hire transformed into a network of 4,000 micro-enterprise nodes operating with zero distance to the customer. These nodes are driven purely by market efficiency, even forcing internal support nodes to compete for their business. Pure flatness carries risks. Valve Corporation operated without formal managers, but the absence of formal guidance allowed a hidden hierarchy to emerge, where informal power was wielded by long-tenured employees. To prevent this, node-based organizations use a specific behavioral protocol, the advice process. The advice process dictates that any node can make a decision, but they are absolutely required to seek input from those who will be affected and those with specialized expertise. Frameworks like the advice process provide the rigid behavioral boundaries necessary to maintain extreme operational velocity without the risk of collapse. Moving to a node-based architecture builds the foundation for multi-agent systems, a structure where specialized AI programs collaborate autonomously to execute complex workflows. Because this structure defines roles by accountability rather than human identity, an autonomous AI agent can occupy a node as easily as a person. This allows for a modular integration of AI that is impossible in a rigid human hierarchy. This schematic details the digital assembly line. Specialized AI nodes handle data gathering and compliance, while human nodes focus on strategic execution. This modular architecture scales indefinitely. The system autonomously prunes low-value connections and strengthens high-impact ones, ensuring the organization remains lean. For executive leadership, this transition requires a shift from acting as a commander to serving as a designer of the network. The future leader's job is not to control the individual nodes. Their role is to engineer the health of the connections, cultivate the shared environment, and define the absolute North Star purpose. Ultimately, future dominance belongs to those firms that operate as a living, self-organizing network of autonomous, high-frequency nodes.